Hello students, in this video we will learn about the power flow diagram of DC generator and DC motor. Similarly, you will learn about efficiency. Okay, first power flow diagram. So DC generator, especially DC generator will delivers the power to external circuit, but DC motor is required supply to the circuit. So supply we will get from the external circuit. So DC generator will develops electrical power from mechanical from which converts mechanical energy into electrical energy. But DC motor which converts electrical energy into mechanical energy. So DC generates produces the electric power. DC motor requires electrical power. So here to the generator what we have to give, we need to give mechanical power. To the motor what we have to give, so we have to give electrical power. Okay, so here we have a power flow diagram. Power flow means how the power is flowing, how the input power converting into output power, how output power is producing. So what is the output power? So we have to learn. So we how we are converting mechanical to electrical using generator, how we are converting electrical to mechanical using motor. So here we have a three blocks in generator. For power flow diagram of generator we have three blocks, and similarly motor we have a three blocks. So as I said earlier, so generator is convert mechanical to electrical energy. So here we need to give mechanical input, mechanical power to the generator. So first you see the first block, mechanical power input equal to output of this output of driving machine, either prime mover, so either turbine if we take. So it is coupled to the generator. So mechanical output of the turbine is input to the DC generator or generator. So input, mechanical power input. So after that, after mechanical power, so generator will produce the iron and friction losses, iron and constant losses. So after that it will develops after reducing the iron and friction losses from the mechanical input. So we will get the electrical power develop. So we can see in second block in generator. So electrical power developed in armature is equal to Eg into Ig. So that will be developed in the generator. So winding will have, so generator will have armature winding and field winding. So due to armature winding and field winding, so due to ohmic resistance of windings, copper losses will produce. So after taking the minus from the electrical power developed copper losses, you will get the electrical output, electrical power output from the generator. So that is called, that is the actual output of the generator. So that is equal to VI watts. Okay, that is the output. So similarly, if you consider motor, so motor is required electrical supply, electrical input, so that will be converted into mechanical output. So here electrical input VI, what we are generating the, so you can see here. So we can see in this figure. So what we are getting from the generator output is VI, that we are giving to the input to the DC motor. So electrical power input to the motor is equal to VI. So after giving electrical input, so there also windings will be there. DC motor also will have armature and field winding. So due to the armature winding ohmic resistance, to the field winding ohmic resistance, so there will be produced a copper losses. So once if you reduce copper losses in the electrical power input, so there will be power developed, mechanical power developed in the DC motor, that is called Eg into I. This will be equal in both generator and motor. So mechanical power will show with Eg and Ia. So once mechanical power developed, so mechanical power develops, then core of the transformer also will produce the losses. Transformer core, motor of the motor core will produce, and friction losses due to bearings, due to wind friction losses will produce. So then if you minus from the mechanical power developed in the DC motor, if you take, that is a motor output in watts. So motor output in watts is equal to P output, that if you give to the generator, so that will be the input to the generator. So if you take output of the motor, if you connect it to the input to the generator, that will input to the DC generator. So this is the power flow diagram of DC generator and DC motor. So this is a very important thing. So you have to learn these diagrams, block diagrams, and you have to explain each block. Okay. So how we what is the mechanical power, what is the power input to the motor and power input to the generator, what we are getting from the motor and generator. So this is about the power flow diagram. Next we will see the efficiency of DC generator and DC motor. So efficiency of the DC machine. So efficiency is defined as the ratio of power output to power input is called efficiency. The DC machine overall efficiency is given by power output is equal to total output of the machine. So power input, P input is equal to total input of a machine. So here we are considering the P out, P in, PCU, PI. So P out means total output of a DC machine, and P in is the total input of a DC machine, and PCU variable losses, and PI is the constant losses. So P input, total input to the DC machine. So here we are considering as a, so output plus losses, or P output plus P copper loss plus and iron loss. So PCU, PI. So losses are copper loss and iron losses. The efficiency is defined as the ratio of power output to power input. That's what P output by P input. Percentage efficiency is equal to P output by P input into 100. So input, what we can write, P output plus losses. So P output by P output plus losses into 100. So efficiency according to that formula, P output by P input plus here sorry, P input. So P, not P input, P output. P output plus losses here. P output plus PCU plus PI. Okay. So this is efficiency of a DC machine. So one more derivation we have, when we will get maximum efficiency from DC machine. So what is the condition for maximum efficiency of a DC machine? So that is condition we have. So when copper losses and iron losses are both are equal, then efficiency will get maximum from the DC machine. So that thing we'll discuss in the next video. So just you remember, P input is equal to P output plus losses, PCU plus PI. Losses are PCU plus PI. So in next video, so we'll see about condition for maximum efficiency. That condition we have, that those things we will discuss. So in this video we have discussed a power flow diagram and efficiency for power flow diagram for DC generator and DC motor. Okay. So next video we will discuss condition for maximum efficiency of DC motor. So thank you everyone. Okay. So these videos we have to watch. If you have any doubt, and you can ask. Okay. Thank you ma.